Hi everyone, and welcome to today's Chemistry Daily Booster. This is number 2 in the series. Do note the purple box is here for the first time in chemistry because this is a topic listed on the advanced information for both foundation and higher tier for those of you doing the separate chemistry. First thing we're going to jump into then is looking at relative atomic mass and relative formula mass. When we talk about the relative atomic mass, that's just the mean mass of an atom of an element that's compared to 1/12 the mass of an atom of carbon-12. That's a really big mouthful of saying that the atomic mass is basically the thing you read on the periodic table for each of the elements. Now, the reason that we use a comparison to carbon-12 and 1/12 the mass of it for that is because when we're talking about the mass of an atom, they are so small, grams just wouldn't work. So we use a comparative term using 1/12 the mass of a carbon-12 atom. When we come on to the relative formula mass, or MR, this is the mean mass of a unit of a substance compared to 1/12 the mass of a carbon-12 atom. Now, in order to actually work this out, all you've got to do is add up. When you are given a question that says work out the relative formula mass, or you're needed to work out the relative formula mass for another calculation, then you need to first of all use your periodic table to look up the relative atomic masses, assuming they haven't given you the question, and then you just add them up. So if the formula was H2O, that tells us there are 2 hydrogens, and hydrogen has a relative atomic mass of 1, and there's 1 oxygen, a relative atomic mass of 16. So 2 times 1 is 2, plus 16 gives us 18 as the relative formula mass for 1 molecule of water. The second bit we're going to look at today is the empirical formula. Now, empirical formula, quite simply, is just the simplest whole number ratio of atoms of each element that we find in a compound. So what you'll find is when we're given a chemical formula, and the example we've got on the screen is butane, C4H10, then this is not the simplest ratio of carbons to hydrogens. If we then are asked to calculate the empirical formula, we need to make that the simplest ratio of carbons to hydrogens. So what we need to do is have a look at our 4 and our 10, pick the highest common factor of both 4 and 10. Hopefully we know that's 2. Then we divide 4 by 2, gives us 2, 10 by 2 gives us 5, and then we can rewrite the formula to be the empirical formula. So C2H5. We're just giving it as the simplest whole number ratio of each of those individual elements in that compound. So highest common factor, divided by the highest common factor, write the new empirical formula. Can we please be careful with how we write formulas on our papers? Do not write carbon with a little 2 up in the top right. The only time a number goes in the top right is if we're talking about charges. That is not correct. It needs to be down in the bottom right. Okay, so please make sure any numbers to do with numbers of an individual atom, always the bottom right of the symbol. When we consider if something is a pure substance or an impure substance, first thing we need to do is know what that means. If something is pure, it consists of only one element or only one compound. Impure substances contain more than one element or more than one compound. The term mixture refers to where we've got more than one element or compound mixed together, but they are not chemically bonded to one another. Good example of a mixture is air. The air you are currently breathing right now is a mixture of oxygen, carbon dioxide, nitrogen, argon, other gases in trace amounts, and they are not chemically bonded together, they're all just occupying the same area. Another term we need to know that will come up again when we do the second chemistry paper is the term alloy. Now, an alloy is just a mixture of a metal with one or more other elements. So keywords there, mixture, and remember that it's a metal with one or more other elements. So we now know what a pure substance is, but how do we identify a pure substance? What could we do to work out if something is pure or not? And the answer is we can do a very simple experiment of just testing the melting point of the substance. Remember, the melting point is the temperature at which the substance changes from solid to liquid. And if it is a pure substance, so made of only one thing, it will melt at a single temperature. If the substance is impure, then it's going to have a melting point across a range of temperatures. So it will not melt at just a single temperature, it melts across a range of temperatures. And that melting point will be lower than you would expect for the pure substance. The greater the difference in temperature between the expected value for our pure substance and what we get, then the lower the purity of that particular thing we are testing. To carry out the experiment then, seems a bit obvious. If we want to test the melting point, we're going to heat something up. So you heat it up and you record the temperature when it melts. There are a couple of points to note here. First, you need to heat the substance slowly. That's because we need to allow the temperature of the whole substance to increase. Otherwise, you're going to have a very hot bit in one region, but a cooler bit in another, depending on the size of the substance, of course. Secondly, we need to stir it. The reason we've got to stir it as it melts is to ensure that the whole sample is at that same temperature, that we're not getting those hot spots and cool spots. It just makes sure that heat is evenly distributed throughout the entire thing. Head on over then and have a go at today's quiz. It's not a long one today, so see what you understand, what you don't understand. If there are still bits you're not sure on, you can obviously look up the videos on the main channel, or you can use your revision guides just to go back over those key bits. Don't forget to join us again tomorrow for our next Chemistry Daily Booster.